Question number 15. At 0900 hours, relative bearing is 30 degrees. At 0920, relative bearing is 60 degrees. Ground speed is 300 knots. Fuel consumption is 600 kilograms per hour. Find the distance, time, and fuel required to destination. So, question number 15. At 0900 hours, the relative bearing is 030 degrees. And at 0920 hours, the relative bearing is 060 degrees. Ground speed is 300 knots. Fuel consumption is 600 kilograms per hour. Again, you have to find distance, time, and fuel required to the station from the closest point of approach. Alright, so at 9 o'clock the relative bearing is 30 degrees, so you can draw the aircraft in any configuration. Make it a bit simpler by drawing it on a northerly track. So 30 degrees relative bearing is somewhat like this, right?
Yes.
Good. And then the aircraft, so this is the NDB here, and the ADF is going to point towards NDB there. Now after this happens, and this measurement is done at 0900 hours. After traveling for 20 minutes, the aircraft is having a relative bearing of 60, which means the aircraft is somewhere here.
Yes.
And this angle is going to be 60 degrees.
60 degrees.
And that measurement is done 20 minutes later. Right? You're asked to find out what is the time, distance, and fuel consumed required from the point of closest approach to a station. So when will you have the point of closest approach?
At 9:20.
Is that the point of closest approach? Are you getting any closer to the station than this? So if I have a station here, and if an aircraft that is passing like this, at what point do you think is the point of closest approach? Point of closest approach means if I want to approach towards a station, where is the shortest? Where will it be the shortest? At what point?
Abeam the NDB.
Once I reach Abeam, now if I start tracking, this is the shortest approach, right?
Yes.
All the rest of it is going to be longer,
Yes.
right? So this is the point where this the point of closest approach. So when the aircraft is here, what should be the relative bearing?
090 degrees.
If the station was here, the relative bearing should be
270.
so either of those. So basically, when the aircraft is abeam the station is when the aircraft is at the point of closest approach. And when will what that happen here? Here, this is the point
Okay.
of closest approach. And this abeam, therefore, it's going to be
90 degrees.
relative bearing of 90. Or this angle is going to be 90, basically. Right? You're asked to find out the distance, time, and fuel required from the point of closest approach to a station. The point, the statement point of closest approach mostly is not given in the question. Usually it's not given, but this is what it means. Right? Otherwise, any other distance is not significant to us. Only the one that is the closest approach is significant. So you're asked to find out this range here. Yes. Now you want some time?
So this
again?
will happen when the time will be, as the speed is constant. So like 30 degrees change is there in 20 minutes. So at 9:40 it will be abeam the NDB.
Okay. Okay. Let's draw another triangle. This particular bearing change is 30 degrees happening between 0900 and 0920. Look at this distance here.
Yes.
Okay. Now, what do you think is this total angle?
9. Okay. This.
You're right. This is 30 degree relative bearing, and this is 90 degree relative bearing, which means this total angle has to be a bearing change of 60 degrees. Just like 30. If this 30 and 60 is 30 and 60 is giving you 30. 30 and 90 should give you 60 degree relative bearing. Therefore, this total angle is 60. Therefore, what is this angle here? This is 30. total is 60, therefore this also has to be 30. The angles are actually, the angular change is the same. Right? Okay, now look at this distance here. And look at this distance here. Let me put one more 30-degree change for you. Here.
Okay.
I'm going to make exact 30-degree change here. Let me extend the line. And look at this distance here. Just because the angle is 30, 30, 30, do you think the distance is the same? No. So you cannot say that this is an equivalent of 20 minutes of a distance at ground speed of 300, therefore this is also the same. No. It becomes smaller and smaller and smaller. And once it crosses the beam, that now grows bigger. Right? Make sense? Yes. Yeah, so you can think again. Which means now this distance is a problem for you. You cannot make it conveniently the same distance as this one. It's very clear from this diagram also. You can see. It's different. Yeah. Did you get the point?
Yeah.
You have to use pure trigonometry here. Now, there could be a different method to do this. I'm not really sure about that. So I've asked a lot of people around about, I have a particular method with me, but I've asked for other methods, but no one has come back with any sort of answer. So I don't know if someone can help you with a different method. Let me know as well in future if you stumble on this question, and if there's an easier method. I don't think so, but because there's no application of 1 in 60 whatsoever here, because definitely the bearing is more than 60. So it's trigonometry coming, because trigonometry is the base of even 1 in 60. So I just took the basics and I developed from there. I don't think there's an easier method, but just in case, I have told the same statement to I think almost 100 students have come to me, but I haven't got a reply so far. And I even asked instructors who teach, they don't even know the method which I am using as well. So most of them haven't even seen the question on the first place. So I haven't got a reply so far. It's basically solving equations having two variables. Equations to degree 1, linear equations, and two variables. How you solve it? The same way. You find one variable from equation, substitute in the other. Alright, let's take the available triangles here, right angle triangles. As you rightly did, we have to name the triangles. That is easier. So let's take this. What point did you give here?
2.
This one?
P, R, and S.
Yes. So I was pretty happy when I saw all those namings and stuff. So I believed you might come up with the answer. All right, let's take the smaller triangle here, right? So what is this distance?
100 nautical mile.
That's right, 20 minutes at the rate of 300 knots. So it's like 1/3, which is 100 nautical miles. The problem is here. I have no idea about the time. Even though I know the ground speed, there is no use, because I cannot take this as 100 nautical miles. Therefore, I can take this distance as distance d. This is a variable here, right? Alright, so let's see this. Let's look at the smaller triangle here. So smaller triangle, the total bearing change is 60. This bearing change is given in the question as 30 degrees between 900 and 920. Therefore, this is also 30, right? Looking at the triangle QPS, right angled at P, I can find a trig ratio connecting the opposite side and the adjacent side, which is tan, and the angle is tan 30. So tan 30 is opposite side, which is D, and adjacent side, which is R. I'm not even sure whether Apeksha is here. Alright. Taking another triangle here, triangle QPR. Right angled at P. Again, I can take tan 60. And again, opposite side, which is 100 plus D. Divided by R. Now, I'm pretty sure that I can solve this. Why? Because I have two equations and I have two variables. If number of equations is equal to number of variables, you can solve it. It's easy, right? So, what is D from here?
R tan
30. I'll take this D and I'll substitute here. So
Okay.
your basic school maths, that's something different here. Same thing. Tan 60 is 100 plus. What is D? D is R tan 30.
C.
The whole divided by R.
R.
Now I have only one equation and only one variable. Definitely I can solve this. Cross multiplying, you will get R tan 60.
And 6.
And then bring this R tan 30 here. I can write this as, and taking R outside, it becomes R tan 30 minus tan 60. That's equal to, what remains here is 100. Therefore R is equal to 100 divided by tan 60 minus tan 30. The answer is just away from finding this tan 60 minus tan 30 and dividing with 100.
86.6.
86.6 nautical miles, that's all. This is the way I do it. That's why I said if you have any other method, if someone tells you, just let me know. You just share this question with your friends or with the instructor, someone, just try if they can do it. And if you get a positive answer, let me know. So that is D. So that is R. So the R is 86. Decimal 6 nautical miles. Now, at a ground speed of 300 knots, you can find out the time that you would take, and you can also find the fuel consumption. Right? Yes. So time is equal to 86.6 nautical miles at a ground speed of 300 knots. That is 86.6. Yeah. How much?
Just taking 17.32 minutes.
17.32 minutes, and therefore what is the fuel required? At the rate 600 kilograms per hour.
173.2 kg.
Let's say 173.2 kilograms. Understood? In the previous question, you couldn't use time change by bearing change, but you could do it straight using trigonometry because the bearings were taken at 130 degree other abeam. But in this question, not just that the angle is more than 20, the bearings are taken not towards the beam. It's taken at 900 and 920 at 30 and 60 degrees of relative bearing. That is why you got stuck in between, because there is no right angle triangle formed in the first place. Not really sure about the origin of this question, because this question doesn't make sense to me at all, because it's such a complex question. Not complex in the sense, I always look into these questions in such a way that if I actually fly the aircraft, will I be able to find this out in no time? I don't think so. I can really lose in the aircraft and find out all these things. So it's time change by bearing change into 60 is okay because it's easy. I had a bearing change into this, time change, that's fine. But this, I'm not sure that there's an easier method for this. But with this method, this is not aircraft friendly. So application of 1 in 60 has to be aircraft friendly, and there is no application of 1 in 60 here. So I'm not sure, this just may be a question for the exam kind of thing. So we have done with the major part of the NDB's sums. So NDB questions are relatively confusing. It's easy, I wouldn't say it's difficult, but it is comparatively confusing. So try doing the questions which you have already done. Have you gone through them once after the class? The questions which you have already done, the sums? If not, go through it. You've done a revision? Yes. Yeah. So because otherwise, generally it is a confusing topic for students. Primarily because it's very difficult to orient you in a direction, because even you have started flying at least, but even for people like Apeksha who haven't flown, it's very difficult to give them a realistic view of you being in the air and then trying to figure out the NDB. So when I say the ADF is pointing towards NDB, they can all they can do is just imagine most of the things. But if you've actually flown, so that's the easiest part teaching conversion students, because they've already flown, they're here just because they want the theory. So when I start talking about NDB, they know most of the things. So they don't have to imagine, they know the reality.